Hi everyone, we're going to find critical numbers for f, and we're going to first take the derivative. We're going to find open intervals where f is increasing or decreasing. So when I take the derivative of this, I'm using the quotient rule. I write down my denominator times the derivative of the numerator minus my numerator times the derivative of the denominator, all over x squared minus 9 squared. And cleaning this up, we're going to get 2x cubed minus 18x minus 2x cubed over my denominator. What happens is these two cancel, so we're going to get negative 18 over x squared minus 9 squared. So let me erase this because I'm going to save room here. And to find your critical numbers, you set this whole thing to 0. My derivative, we're going to find critical numbers, you set this to 0. And the denominator would cancel, and you get x equals 0. So we have a critical number at x equals 0. However, in here we have 2 points of discontinuity, because you can factor that as x minus 3 times x plus 3. You can put the square there if you want. And that would make the denominator 0 if x was 3 or x was negative 3. So this is my points of discontinuity, and this one is my critical number. So I'm going to use all three of these to help me with my test intervals. Alright, so my test intervals, okay, let's write it down. I'm going to write them in order. We have negative 3, 0, and 3. So we're going to go from negative infinity to negative 3, and then negative 3 to 0. Whoops. I'm trying to go too fast. Alright, to 0. And then 0 to 3. And then we have 3 to infinity. And we got to test to see if the sign is increasing or decreasing, or positive or negative. So let me write down the derivative. Our derivative was negative 18x over x squared minus 9 squared. So for negative numbers, if I plug in a negative number in the numerator, so if I plug in, say, negative 4, I'm going to get a positive in the numerator and a positive in the denominator. Okay, so this means my sign is going to be positive. For this one, if I plug in negative 2, say, the same thing happens. So this is positive as well. Now let's see what happens when we get above 0. So if we plug in 1, if I plug in, say, 1 for this one, I'm going to get a negative in the numerator. The denominator, I'm going to get a positive because you're squaring it. So that's going to equal a negative. So my sign is negative. And the same thing's going to happen if I plug in, say, 4 or 5. Your denominator is going to be positive, but your numerator is going to be negative. So in this case, my this is increasing and increasing. I can just put plus plus. And these are decreasing. So these two are increasing, these two are decreasing. Now, as far as our, so basically if you look at it, you have increasing, then increasing again, then something decreasing and decreasing. So we are going to have a relative maximum. And I'm going to use my middle point here because it's changing, where it's changing from increasing, decreasing. So this is decreasing, where we're making the changes right in here. And that's with the 0. So I'm going to plug in 0 to my original equation. So my original equation was f of x equals x squared over x squared minus 9. And if you plug in 0, you're going to get 0 over negative 9, which equals 0. So I have 0, 0, and that's going to be a relative maximum because we're increasing first and then we're decreasing. So that's a max. Okay, thank you. Have a nice day. Bye-bye.